I'm Manav from the Rollkit team at Celestia Labs. And my presentation is about having uh, how we construct a POC for constructing ZK IBC from an EVM chain to Celestia ZK accounts. So from space, Celestia, it does not have a VM to minimize on-chain state. It only state it has is just sending addresses, and it has like a large, like the most amount of thing it has is just blobs. So you can just post blobs to it. You use it for DA. So it can only send and receive TIA, its native asset, by IBC. Currently, there's a token filter. And that means that native rollups of Celestia, they cannot form a trust minimized bridge to it, right? And by adding a ZK verifier for rollups, Celestia wants to enable rollups to form trust minimized bridges to it. And this means this is what we call like a Celestia ZK account. So each chain is a ZK account. And the only state we add here is just a verification key here. And Rollkit is it's a stack for Celestia's native ecosystem of applications, which do not have an enshrined bridge, unlike the current L2s. So forming a bridge to another chain currently requires relying on a committee-based bridges, because each chain that spins up is just an island in itself, and there's no way to form a trust managed bridge to Celestia. So we want the ability to establish that a trust managed bridge to another chain, starting with Celestia via a new IBC client that verifies the entirety of state transition of a rollup, which comprises of a folk choice rule, an optional ordering rule, and a execution proof and logging tree bridge, basically a function. So solution, you just want to come up with a POC to figure out like all the necessary components you need to establish a trust managed bridge. So what is the end-to-end workflow to go from vanilla, like type 1, ZK EVM. So take that and then figure out like what are the pieces needed to go form this trust managed bridge. So that was kind of the goal. That's a solution we have. And I just drew this last night on my were all the components. So you can think of like a chain as just an application on Celestia, just because it's just a function of Celestia. So you can, with SP1, you can just prove the entirety of that. So going from an arbitrary set of blobs to a folk choice rule, arbitrary, it could be a signature of a sequencer if you really want to use a single sequencer. You can combine it with the execution proof and combine it with the blob inclusion proof. So you aggregate this whole thing, and that's what you use. And you run like this operator sidecar, which we took from the IBC team. And we used that to update state on Celestia. So the only thing Celestia needs is just keeping track of what is a state root and a verification key. So we minimize or we add very little state to Celestia per chain. And in order for withdrawals and timeouts, there is this is following the IBC spec. There's also like inclusion and absence proofs that you need to verify. So on Celestia, and we just wrap this with a ZK proof in SP1 instead of verifying it all on Celestia. So all Celestia just verifies proofs, and that's kind of all you really need. You don't need smart contracts to form a trust managed bridge. So that's what we do. What does SP1 unlock? It SP1 converts just chains to just apps. It's like a succinct way to put it. But an application is just a deterministic function of Celestia blobs, right? So an arbitrary set of blobs, you can just define how do you go from arbitrary set of blobs to a canonical state root. So it could be like you could do all kinds of things like from random proofs of proofs of X, if you want to do proofs of web proofs, to construct blobs together. You don't need like these single sequencers necessarily if you really don't. If you have a really fast base layer, which is what Celestia's plans to be, and you can kind of configure everything to how you go from that set of bytes to the state root, even like multiple current proposers and stuff. You can just kind of have anything, right? So since it's just a function, you just prove the entire function in SP1. This means we can reduce an entire set of rules of a blockchain to just an SP1 verification program, which is just an application, right? End of the day. And this set of rules just can be verified on any other application or chain to form a trust managed bridge. And like this kind of, you can, with SP1, you can just have a trust managed bridge to any other chain. It doesn't have to enshrine a single bridge. So it makes the whole idea of needing a settlement layer sort of unnecessary, and it just makes chains applications. Yeah, next steps, just want to put all these pieces together to create an end-to-end demo, going from an EVM chain application like to Celestia and back, and you can kind of do with that to any chain. Then, yeah, and links to repos, documents. I mean, there's this really good talk from NashQ from Celestia Labs called ZK accounts, and all the kind of things that unlocks for Celestia, from liquid staking, restaking, all trust minimized. So you can watch that if you're interested in learning more. And here's like Rollkit's Twitter, where you're like kind of trying to figure out the most like sort of expressive stack to build from this arbitrary set of blobs to a state root. So kind of covering that entire design space. So yeah, that's us.
Great. Thank you so much, Manoj.